So let us start with the creation of Antarctic bottom water. The mechanism or the process that leads to the formation of Antarctic bottom water is called slope convection. Okay? Convection, the movement of dense water downward on the continental slope. And what drives this formation is convection in so-called polynyas. And polynyas are regions, ice-free regions, and otherwise ice-covered polar regions. Again, there are different mechanisms that can create these polynyas, and we discussed that in the lecture. But essentially, you get a massive heat loss if you open up the oceans in ice-covered region, and the heat loss can be more than 1,000 watts per square meter. And essentially, it forms new ice, and if the wind removes this new ice, the salt is left behind, and you essentially increase the salt concentration in the water, and that makes the water very, very dense, cold and dense. And this is shown in this sketch here, the mechanism of the formation of very, very dense water. It's also facilitated by the existence of relatively shallow water. So we are on the continental shelf, and the shallow water constraints can enhance the formation of very dense water. And the dense water then, in interaction with the seafloor, can spread into the deep sea. It's not as trivial as you might think because of the Earth rotation. So you can essentially have a mechanism in very, very close to the seafloor known as Ekman drainage and bottom Ekman layers. But we also know that a submarine canyons and channels play a big role in guiding the dense water down the slope in terms of canyon flow. Okay, so this is this process of slope convection. And let's have a look at some examples of this slope convection. How can you identify the process of slope convection?